Hello, everybody. Welcome to KCP Community Meeting. Today's July 3rd, almost midsummer. Thanks for joining. As always, this meeting is governed by CNCF Code of Conduct, which boils down be excellence to each other. So no swearing, no stabbing, and be good. Before we jump to aka empty agenda today, I want to give a chance to new people to introduce if we want to. It's optional. Anybody?
Yep. So, hi, my name is Sudhanshu, and I basically belong from India, and I basically work in DevOps domain and IT ops domain, where my primary task is basically on-premises infrastructure management and cloud infrastructure management. So that's about with myself. Thank you.
Cool. Nice to have you here. Lucas?
Sorry, that was an accident.
So do you want to introduce yourself or just an accident wave?
That was supposed to be a wave, yeah.
Cool. Okay, so as we had a small pre-discussion today, our agenda is quite empty. So before I hand over to Christoph on his performance testing discussion, is there anybody else who has something we want to add to the agenda? Going once, going twice. Okay, Christoph, floor is yours. If you could give a bit of introduction why you've been looking to this and like what's the
because of Lucas. Lucas is working on something related to that and had questions. And we were looking at how much we can get out of a KCP instance. And to do that, I began to run some very simple tests. I installed KCP as a single shard, just with a front proxy in front of it and external etcd into a kind cluster. I've used the normal KCP hand charts to do this. And then I simply added one workspace every 10 seconds, very slowly, to give KCP time to digest it all, to see how far can I stretch a single KCP shard. Most importantly, I was looking at the memory limit here. So the Go mem limit environment variable. And what I found is that KCP scales nearly linearly. So if you give KCP 900 megabytes worth of memory, you can have 300 workspaces. Because one workspace costs you roughly 3 megabytes of runtime memory. If you give it 1,500 megabytes, you can have 500 workspaces. If you give it, you can do the math for yourself. So it scales pretty much linearly. We also know, if I remember, I think Robert, you talked about this, about leaking coroutines. So if you then delete workspaces again in the same running process, you won't reduce the memory footprint and you won't get back to a happy KCP. If you reach the limit and then you delete it again, memory won't go down. And the most interesting thing for me is that the CPU usage of KCP is mostly linear, relatively low, it just chills until you hit the memory limit. Then the garbage collector takes over and then your KCP instance is basically dead. It goes on my small laptop here from a load of basically nothing to maxing out all CPU cores. And that happens pretty much instantly the moment you hit the magic number of most max workspaces. Restarting KCP won't help you. Like a full KCP will always go into GC mode. It doesn't matter if it's just has been running for a day or so. If you delete workspaces and restart your KCP, that indeed has an effect, right? So we don't leave any tombstones behind in etcd that cause additional load afterwards. So cleanup is good. But there is a very clear limit to how many workspaces a single KCP shard can support. All of these workspaces were empty. There's nothing happening in them, and that's the baseline of roughly 3 megabytes. If I had to guess a workspace where things actually happen, anywhere between 5 to 10 megabytes per workspace, I really purely guessing here. Absolutely no idea. So that's my finding for now. At the moment, I'm testing the same thing with a sharded setup using the KCP operator instead, because I'm not super familiar with the Helm charts to install a sharded KCP. That is running right now, and I expect my 3 KCP shards, each has 1 gigabyte, so 3 gigabytes in total should give me roughly 1,000 workspaces before the shards should begin to destroy themselves in terms of CPU. We did all of this because the KCP Helm chart also sets the go max prox variable to limit the amount of CPU. Unfortunately, I haven't yet understood why it sets the limit to the Kubernetes CPU request. That seems kind of counterintuitive to not set it to the CPU limit, but I haven't investigated it. And it also seems generally counterintuitive. If your KCP is really CPU spiking all the time, that's apparently a very clear sign that you're just memory starving it. And putting a CPU limit on top of the KCP that is in garbage collection mode will not help you. So we might need to adjust the Helm chart a little bit and tweak this a little bit. The third finding is the minimum amount of memory I can give a KCP is 150 megabytes. Anything below that and even empty blank KCP will just go into garbage collection mode and be unusable. That's my findings so far. There weren't any metrics in KCP that I could see at the moment that tell me how many workspaces there are on a shard or logical clusters there are on a shard. But with this knowledge of roughly 3 megabytes per workspace, it would be extremely helpful to know this, because then you can really calculate based on your memory limits how far you can go and act before KCP suddenly flips into, oh God, everything is hell, I'm doing garbage collection now. So that's my presentation. Questions, comments, concerns?
3 megabytes rings a bell. I think our friends did the similar ones. Like, we know the company which don't go public about using KCP. I think I just searched the Slack history, found the similar references to around 3 megs.
Yeah,
So,
this wasn't rocket science. I just did the very bare minimum.
So I'm okay. It would keep a notes on this setup. I think it will be very nice, interesting to see once the Nilo changes merges for the like garbage collection, like context stuff, like the basically cleaning of the workspaces, because we know where it's leaking. Another one which would be nice thought experiment. So we know we have this patch on top of Kube for the garbage collection, where we start one garbage collection instance per created workspace. And I think that's the majority of the usage, if I recall right. Would be interesting thought experiment to, let's say, have a temporary disable that patch, means no garbage collection as such, run the test and see what's the footprint of memory in there. Solely so we know where the hotspots are. Maybe if you have a pprof dump, like you don't need to do that, and we can already spear hotspots. Because like I think the value here would be to understanding why do we need 3 megs in the first place? Can we optimize to something like, because the number is so low, even 30% optimization will give us a lot. So I'm just
Ironically, I haven't yet managed to convince the pprof endpoint to give me data. It always says unauthenticated. And I can get metrics, I can get everything out of my KCP shards, but it's not letting into the
try
pprof
using
endpoint yet.
that dash kubeconfig dash s. I think there is a, like, if you provide admin kubeconfig, I think you can get it out from there, basically.
I haven't really put a lot of time into it,
Yeah.
into pprof.
And this meeting is being transcribed by our friendly Gemini AI. So I think if we can, I'm gonna try to generate a mini report from what you gave. I think it's a good findings to put somewhere in our docs. If it
Yeah, I was
fails,
wondering where we
I
should
might
put
come
them.
back to you to sanity check the AI work on this.
Sure. Zilo.
I'm thinking of how we can prevent something like this from happening in production. I'm thinking if it would maybe make sense to give shards a maximum amount, a configurable maximum amount of workspaces that defaults to something like 500 that is unlikely to be hit in quote unquote normal usage. And then people that do need a shard, that actually do need more workspaces, can just increase it through the configuration, but it would make the issue very explicit. So it's not something that people run into with having, then going into this garbage collection bonanza and then not being able to save that shard. But without going into etcd and so on. I mean, we could also set this dynamically. Not sure if we can. I mean, we can query the mem stats through Go runtime, but I'm not sure how this works in Kubernetes. If it shows just the entire memory from the host it's running on, or the memory allowance or something. Yeah, but that's something to think about to prevent this from happening in production.
Can we even do this? I was thinking that workspaces, when you create them, are hashed and then spread across all shards. Wouldn't the front proxy then need to know about the limits of each shard? And
I mean, I'm not too firm on this, but I would presume that if you ask a shard to deploy a workspace, that the shard can decline. Because the shard should
front proxy would go
know.
onto the next shard, and then
Yeah, exactly. Yeah.
hope that still finds one. So we might need to keep some topology information in the front proxy.
So that's
When we can, we don't have to. If it's just going through the shards, then only the shards which should know how many workspaces they actually have and serve, they can just say, no, I can't serve anymore.
So front proxy has this information already. There is a basically in-memory index of every workspace per logical cluster, per shard, per everything. So the data is there. And I think that soft limit could be introduced on the just front proxy level, just checking basically length of the index simply. And yes, the creation is a very much round robin, like create fire to shard and expect it to accept it. So maybe create an issue in GitHub and we see if we can sort it out in a couple hours from proxy index magic. I think it's forfeit. If it takes more than that, we might need to go back to drawing board. It would be like a soft front proxy rate limiting of some sort.
So the hashing alone is not enough to figure out where a workspace is. I was always thinking the front proxy takes just the path or the logical cluster ID, hashes it, and then, okay.
No, it's this is why, if you recall, we had a conversation some time ago about potentially adding many root workspaces, like a forest. And that implementation is a bit hard because when you create a workspace, it's kind of randomly chosen. So you kind of need to introduce some randomness in that. Like all the scheduling targeting, you can target by the label selector, but if you don't, it's just random.
Okay.
Nilo, can you just like kick off a GitHub issue? Like, as per discussion, 500 is the limit. Look into how we can soft limit it at front proxy level. And that's it basically. Thank you very much.
If we set 500 as a soft limit for now, then we might need to adjust our Helm chart, because I think the Helm chart provisions significantly lower limits for stuff.
No, I mean 500 workspaces, or are we talking about the memory?
No, 500 workspaces is like 1.5 gigs you need at least. And I think the default limits in the KCP Helm chart are lower than that.
Okay. I mean, it should be configurable, so we could just put in 500 as a magic number default in the code, and the Helm chart can then, reconfigure that as needed.
I'm just wondering, do people know, this, how this pod API called when you call, like, and you get your own namespace? It has this funky name. Like, I mean, pod can query Kubernetes and know its own namespace, its own fields. I'm wondering if it can access its own resource limits. If it could be dynamic. But again, issue, and we can discuss in there basically.
No.
I would have guessed that that should just be available, that Kubernetes sets the limit on the container and Go can just read the limit it has, so without even touching Kubernetes.
No, I would have. I do remember that wasn't the case in the past, but it really just a matter of how the container manager wraps the container process. And I know that because I've been working on a single process kube implementation, and there I've seen that they do already intercept a good number of requests, and this could be one of them by now. So it would really just be something that we have to look into. It might be just present, and then we can just use the Go runtime, and then the memstats.
I would vote that we make this limit configurable of anything, because we're calculating with only my findings on my small laptop over here on empty workspaces where nothing is happening. So there's a good chance that by default the workspace is 5 megabytes.
Yeah, the default should just simply be sane, and there would be great if we could calculate it based on our experiences, and then the user can override it if they want to. And I wouldn't introduce a hard limit because we don't know what people do with the software.
Yep. It's an interesting can of worms.
I mean, maybe just to add to that, I think this finding is really good and very interesting also. But just to add to that, like Stefan Szymanski once said in one of his talks that it should be possible to have like 1 million workspaces. So if we then look at the memory footprint of that, that's quite intense. Right?
I remember that too. And I was surprised that it's 3 megabytes per workspace. I also thought it's just a prefix in the database.
Yeah.
Why is it so expensive? But then I realized that Kube is not cluster aware, so of course you have to start each controller individually.
Yeah, and we do launch a number of controllers per workspace, and that's the core problem. And these controllers do run their own controllers as well. So,
yeah, for me, the primary target is the garbage collection patch. Like, if we can prove that guy is like, if we can find the root cause, I said where it is, we can start looking how to optimize that. And for the record, 1 million workspaces. He didn't say how many shards he has, so.
That's true, yeah.
But
globally.
yeah, like even if we achieve like 30-50% improvement, that will be huge. So yeah.
Oh, good. That was my only topic for today.
Interesting discussion for this hot day. Any
That's all
other
right.
topics? Open floor. Questions, discussions. Cool. So I'm gonna answer this. The question is like, if you want to contribute to KCP, where do you start? What's the beginning friendly issues and things like that? So let me share a screen. As I had this open. Do you see my screen?
Yeah.
Yeah. So we basically try to keep as clean backlog as possible in our GitHub issues. So I think that's the first place where you want to look. We usually tag first good issue, which is the easier ones. I think people have assigned them, but I know, for example, not everybody's working on those, so we can remove them because I think people been assigning to them. So that's the first place to look. But if issue doesn't contain this one, you basically just look through the what's on the top, what's not assigned to the people. And next thing would be, if you find something, go to our KCP dev Slack channel and just ask in a public. We're quite open to having these discussions and guiding you through the issues, even if that is like, I want to find something. Like example, committed package should be unit test. Oh, that's already assigned. Okay. So that's one. We have docs itself is basically in a here. We love people to contribute to those. It's basically we live in the same monorepo. Docs a bit harder to know what to contribute, so I think it's one of those. Pick up the KCP itself. Like we have some tutorials, quick starts here, and try it. And if you find some inconsistencies, the PRs are very welcome. And one more, if I think
docs and then /contrib.
yeah. We have additional repository, which is not yet linked, is a contrib, which is backed by KCP contrib repository. Here we're putting all the slides, content, and things like that of how to basically about KCP itself. So one of the good starts is we had that talk. Where is that? Learnings. Here we go. So it's a self-driven workshop. I think this is, at this point, one of the better place to learn KCP and understand what it does. So if you go through this, you can see, you can try KCP yourself, see what it does, how it works, and from there, you might have more places where to contribute and how it works. We fully understand that learning curve of KCP is quite high. There is a lot of foreign terms and terminology. So just ask questions in our Slack channel. We are a very friendly bunch of folks. Maybe not few of us, but most of us are. So jokes aside. Cool. I hope this answered this. Again, GitHub issues and a contrib repository in there. I'm gonna post a link in a chat for the learning materials because it's a harder one to find. Cool. Any other
We
question?
also have this label good first issue.
Yeah.
They're not many, but they should be relatively or easier to start with.
Yeah. We tend to sometimes forget to stab that label. So if you scroll through them, you don't find anything, just again, ask in a chat. We will be more than happy to find something and send your way. Cool. Any other questions? Okay, Slack channel. Yes, gonna share the Slack channel. Copy link. That will be Kubernetes Slack. If you are not on a Kubernetes Slack, you might need to get invite. But just Google Kubernetes Slack's invites. There is this floating web page which automatically sends the invites. I think we changed it quite a few months recently, and I don't know where it is now. Cool. Yeah, and the channel name, if you get somewhere in different ways, and is KCP-dev. Cool. If nothing else, I will give you 30 minutes back to your day for ice cream, cold coffee, or just walk around the house. Thank you very much and see you in 2 weeks.
Thanks.